Okay. Next page. Okay, here the contents. What is the contents of the unit 4? Here the differential transformation. In this discuss about the differential transformation is the one is the partial differentiation and one is the fully derivation. Here the what is the derivative and differential transformation means partial differentiation is the 50% and differentiation is the 100% of the each transformation and manipulators. And next one is the what is the Jacobian matrix. Here the Jacobian matrix involves to the many of the other links, the link 1, link 2, link 3, like that. You can see the many of the products. Next, what is the dynamics? Dynamics, it is the moving position in the two formulation methods. One is the Lagrange and Euler, and second one is the Newton and Euler. Okay, next you can go to the differential transformation. The differential transformation, 1 minute. Okay, the differential transformation means the purpose of the this chapter is to introduce you to robot motion. And next one is the differential forms of the homogeneous transformation can be used to examine the force velocities of frames. Next, this method will be compared to conventional dynamics vector approach. The Jacobian used to map motion between the joint and Cartesian space in essential operation when curvilinear robot motion in curvilinear robot also discussed in the previous chapter. That is the curvilinear motion means you can move the zigzag position. Okay, here the first one is the left and second one is the forward and next one is the downward and again the inverse direction. So these are the directions will be called as the curvilinear robot motion is required in application such as building or assembly. Okay, he can know about the clearly what about the differential transformation and manipulator. Here we can go to the first point. The purpose of this chapter to introduce your robot motion. Here the robot motion is in the five categories. Two categories mainly. One is the translation and second one is the rotation. In rotation motion, you can move the 0 to 360 degrees and translation is in the 0 degrees to 180 degrees or 270 to 90 degrees will be moved into the particular position. What is the homogeneous transformation? Mainly, homogeneous transformation matrices can be possessed the velocity. For example, V is equal to 2i plus 3j plus 4k is in the velocity frame. The velocity frame will be converted into the matrix form. That is the 4, 3, 2, 1. Okay. Next slide. What is the purpose? What is the purpose of the differential transformation? The differential transformation is the chapter introduced the robot motion, and next one differential forms of the homogeneous transformation can be used to examine and the post velocities of frame. This method will be compared to conventional dynamics vector approach. The Jacobian also be used into the Jacobian matrix is used to map motion between joint and the Cartesian space, an essential operation when curvilinear robot. Here, this point is the most used into the Jacobian. Here, the Jacobian matrices we can differentiation. For example, cos theta is the differentiation term sin theta, and sin theta differentiation is the cos theta, and one is the differentiation 0. 0 is the differentiation is the 0 by 1 is the infinity. Okay, here these are the differentiation terms. Okay, and what is the first point? The purpose of this chapter is to introduce you to robot motion. Here the how many robot motions will be there? Here the number of positions will be upgrading in the type 1, type 2, type 3, type 4 material like polar, spherical, cylindrical, and like spherical robot and scalar robot will be positioned is the very different between the but main work is the pick and place robot, but the place of the pick and place robot is the most variety in the nature. Like you can go to the automobile sector, The car assembly will be open. The car door is open into the one face to another face. He can move the upward and downward direction, and base plate. He can attachment is the robot. Here the various approach methods. That is the Newton Lagrange's formulation also be used. Lagrange's. So here the what is the main differences between the Lagrange's and Newton Euler. Here this topic will be discussed into the latter. Next you can go to the next slide. Okay, in particular you will the differential transformation. First review the differential transformation. Which differentiation? Partial differentiation or fully differentiation? First, that is the two selections of the review. Second is the consider the screw velocity matrix. Next, third one is the relate differential transformation to differential coordinate planes. Okay, here the differential transformation to different coordinate frames. Here the different means, for example, 1 0 0 0 1 0 0 0 1 is the identity matrix. Okay, for example, this is the one matrix, and second matrix I x x1 0 0 0 I y1 0, next 0 0 I z z1. Okay, here this is the one matrix, and next you can go to the next matrix I x x2 0 0, next 0 I y2 0, next 0 0 I z z2. Here the total three matrices. Just you have to compute the this relation between the differential transformation is two different coordinate frames. Use differential transformation determine velocities and frames. And next one is the determine the Jacobian for serial robots using Waldron's method. And next one is the determine how to determine the Jacobians for parallel robots. And next one is the examine. First of all, you have to examine the robot singularity. Singularity means various approach methods. Here my robot is in the two rotations and one translation. No, my robot is the one translation, two rotation. No. So these kind of nature will be there is in the examination of the robot singularities. And next, you can go to the next slide. Okay, next, what is the differential transformation mainly? Mainly in the differential transformation, displacement. Displacement means the moving position is one position to another position is called the displacement, and made relative to the primed axis dp d theta expressed in primed axis, and change the form of dt. Okay, this one is the differential transformation. And next one is the next slide. Okay. Differential, this one is the differential transformation. Here the differential transformation, you can write the given relation. Delta is equal to t for t into delta t inverse, or you can write as the delta t is equal to t inverse into delta. Okay, here here we can relate the differential transformation relative to the base frame or relative to the offset frame t, where t is known as t. We can write as the first position A, second position B, and third position is the C, and third position is the P. Here it is also related to the identity matrix for order of 4x4 matrices 1 0 0 0 0 1 0 0 0 0 1 0 0 0 0 0 1. Here the identity matrix like 4x4 matrices. Just you can insert the AX, B, BZ, CX, and the PX. Okay, PX is the distances between the position. In problem also you can see the problems also you can see the different approach methods, and like that 1 minute. Okay, for example, one linear transformation you can take that. The position of the end effector is 5, 7. Subjected final transformation linearly 5 units along the direction. Here, the along the direction is called as the px, py, and pz. Okay, px, py, and pz. And next one is the direction of okay, here the px, py, pz is the units. Okay, in problem, just you can see the problem on problem. The position of the end effector is 5, 7 and subject from transformation linearly 5 units along the direction of x. Find the final position of the end effector. Here the xyz is the 5, 7, 0 and you can add the plus 5, 0, 0. Here you can add the 5 plus 5 is equal to 10 and 7 plus 0 is equal to 7, 0 plus 0 is equal to 0. Here these examples of the differential transformations. Next slide. Next. Okay, you can see the example of differential. Next slide. Next slide. Next slide now. Next, you can go to the differential solution. Next one. Just you can go to okay. Stop. Stop the PPT. Just final about the differential solution. You have to the delta T power W. First you can apply the V is equal to delta T power N. Next W is equal to rho. Here the rho is the here the 2 is the Px and Py. And here the 1 0 0 0 1 0 0 0 0. Here the x position and y position. Here the U is equal to delta is equal to this product and T is equal to this product with a combination of cross circulation. Now that the same values are obtained. Okay, these are the most apparent example in university questions also. You can ask this type of questions. Okay, thank you. Next you can go to the next session. You can discuss with the differential motion summary. Okay, what is the differential means you have to calculate the most of the differential methods will be used into the this technique. The differential motion will be used in the nowadays you can use the Jacobian method. The Jacobian methods will be relationship for most difficult to obtain the robots. Okay, in the Jacobian deals with the how the rate will be used into the particular role of the dimension and how it is molded to the one phase to another phase. Okay, that is the reaction between the one term to another term. Okay, next session you can go to the tomorrow session on Jacobian. Okay, Jacobian will be discussed into the next class. Here you can stop the